Okay, welcome to Physics for Real, and today we're looking at refractive index. So what does that actually mean? Well, you can see here we've got a ray of light and it is traveling into a glass block, and this material outside the glass block is actually going to be air. And you can see that the light refracts. So what that means is, as it goes from the air, you've got here the angle of incidence, the angle between this ray of light here. So this is a light ray. The angle, let me write that a bit more neatly. So that is light. And that ray of light is going into the glass block, and you can see the angle of incidence, and then it bends actually towards the normal. And you can see that this angle of refraction here is a smaller angle than the angle of incidence. So the ray of light is bending towards the normal when it goes into the glass block. And the question is, why does that happen? Well, it's all to do with the speed of light. So the speed of light in air here is going to be greater than the speed of light here in the glass block. When the light goes from air, which is less dense, into the more dense glass block, it's going to actually slow down. Okay, so we've got the speed of light in air, and if you know anything about light, you know that the speed of light in a vacuum is 3 times 10 to the 8 meters per second, and the speed of light in air is basically the same as that once you round it up. It's slightly slower than 3 times 10 to the 8, but when you round it up, it comes to 3 times 10 to the 8 meters per second. So that's the speed of light in air. And then if you look at the speed of light in a glass block, in glass, the speed of light is about 2 times 10 to the 8 meters per second, roughly, okay? So, as I said, the light slows down when it goes into the glass block. That causes it to bend towards the normal. We'll have another video that will look at why that is later on. But we have this thing called refractive index. So what does that mean? What does the refractive index mean? Well, the refractive index of glass turns out to be roughly 1.5. Okay, so refractive index is just the ratio of the speed of light in air, or strictly speaking, the speed of light in a vacuum. So maybe I should change that. It's strictly the speed of light in a vacuum, which is commonly known as C. That's the speed of light in a vacuum, divided by the speed of light in the material that we're looking at. Okay, so if you look at the speed of light in air, in a vacuum, it's 3 times 10 to the 8 meters per second. And then if we divide that by the speed of light in glass, that gives us the refractive index of glass. And if we work that fraction out, it comes out as 1.5. So the refractive index of glass is 1.5. And all that's telling us is it is the ratio of the speed of light in a vacuum to the speed of light in the glass, or you could say it's the ratio of the speed of light in air to the speed of light in glass. So all that a refractive index tells us is it's the ratio of two speeds, the speed of light in the material that it's going from into the speed of light in the material it is going into. It's the ratio of those two speeds. Okay, so that is what is meant by refractive index.